Good morning, dear children. So, in the previous classes, we have discussed the climatic controls and the factors affecting India's climate. And before watching this particular video, please go through that videos. Then it will be very easy to understand. Okay, so today we are moving on to Indian climate. In the first class itself, I told you that the climate of India is described as monsoon type because in Asia, this type of climate is found mainly in the south and southeast. Okay, so Indian monsoon. So actually, monsoon is a type of periodic wind or a seasonal wind. Okay, so this is experienced in the tropical area, roughly between 20 degree north and 20 degrees south. That means 20 degrees north and south of the equator. Okay, to understand easily, to understand the mechanism of monsoon very easily, we have to go through a set of facts. Okay, shall we go? So about 75% of the total annual rainfall in our country is received by the two monsoon seasons, two rainy seasons. Okay, so this word monsoon was derived from the Arabic word and it is a type of seasonal winds. And actually monsoon, it is the rhythmic wind movement. Okay, that means seasonal reversal of the existing wind system that we are calling monsoon. Here in India, we experience two types of rainy seasons. Okay, that is one southwest monsoon and another one northeast monsoon. Okay, so these two monsoon seasons are described as the backbone of Indian economy, or more clearly we can say that it is the backbone of Indian agriculture. The farmers depend on the rainy seasons for their cultivation. So different crops need different types of rainfall. That means annual rainfall. So this particular condition influences the agricultural scenario, not only agriculture, the economic activities in our country. That means more than 60% of the population in our country is directly or indirectly they're related to agriculture. Okay, so monsoon plays an important role in this aspect. Okay, so let us check which are the facts which control the mechanism of Indian monsoons. So here you can see some facts that controls or influence the mechanism of monsoon. So first among them is the differential heating of land and water. As we all know, the land and water heating, the rate of heating is different. That causes the seasonal reversal of the existing wind system. Then second one, the intertropical convergence zone or ITCZ. So the shifting of ITCZ over Ganga plain during summer. It is the main cause of southwest monsoon. Okay, then the high pressure area east of Madagascar affects the monsoon. And due to strong vertical air currents and formation of high pressure over Tibetan plateau, that means the plateau gets intensely heated during summer. That is also another fact. And the last one is southern oscillation affects the monsoon. So we can say these are the important facts, important factors influencing the monsoon or which controls the mechanism of monsoon in India. So we can discuss it one by one elaborately. So the first fact is the differential heating and cooling of land and water. That means during the daytime, the water or the water bodies, oceans and seas get heated easily or yes, easily than the land masses. So the temperature variation which control the pressure gradient give rise to the wind system, the reversal of the wind system. So the differential heating and cooling of land and water creates low pressure on the landmass. That means they experience high temperature, while the high pressure is created over sea because they have low temperatures. So during the daytime and nighttime, the wind system is reversed. Okay, Yes, that is the first reason. Then the second condition is the shift of the position of intertropical convergence zone or ITCZ. In summer, the equatorial trough, normally positioned about 5 degrees north of the equator, moves over the Ganga plain, creating a monsoon trough during the monsoon season. That means the low pressure. Okay, as you know, the winds or the air moves from a high pressure region to a low pressure region. Okay, then I will show you what is ITZZ. What do you mean by ITZZ or intertropical convergence zone? Okay, actually this is a trough of low pressure because low pressure is seen where the temperatures are high. Then can you say where we can feel the low pressures on the earth's surface? Yes, in the equatorial region. That means in and around the regions of the equator. So, due to the spherical shape, they experience that areas in and around the equator experience high temperature. That means they create a low pressure region. So the easterly trade winds in the north and southern hemisphere, then the northern hemisphere and in the southern hemisphere will be attracted to this low pressure area and they converge in that particular region. Okay, this is where the northeast and the southeast trade winds converge, and this convergence zone lies more or less parallel to the equator. But what happened to this ITCZ that moves north or south of the apparent? It is due to the apparent movement of the sun. That is due to the tilting and also due to the revolution of the earth around the sun. Okay, so this is what is called ITCZ. Can you watch it clearly? Yes, this is ITZZ. It is seen in the equatorial region. It is normally called as a low pressure region where the northern and southern easterly trade winds converge. Okay, so shifting of this ITZZ causes monsoon over India. Then the third condition is the presence of high pressure area that develops east of Madagascar. So Madagascar is the island which is situated in the east of African continent. You can see it here. So the high pressure area created over the east of Madagascar will be attracted towards the low pressure regions over India. So this is Madagascar. So the high pressure area east of Madagascar, approximately at 20 degrees south over the Indian Ocean, it is intensely the intensity and position of this high pressure area affects the Indian monsoon. That is the third point. Okay. And the next one is the Tibetan plateau gets intensely heated during summer, which results in the strong vertical air currents and the formation of low pressure over the plateau at about 9 kilometer above the sea level. So it will attract the winds or air from the surrounding high pressure region. That means the winds that is mainly coming from the oceans and seas, they are moisture laden, and this low pressure which attracts these moisture laden winds from the ocean will cause the rainfall or the monsoon over Indian peninsula. Okay, so these are the important facts of the mechanism which influences the mechanism of Indian monsoon. So apart from these facts, here you are provided with a video regarding the El Nino and southern oscillations. Okay, so you can watch it very clearly from this video. So please watch and please go through the textbook. So it will help you to understand more easily what is El Nino and what is southern oscillations. Okay.
In this video, we are going to learn about ENSO, E-N-S-O. If you break it, EN stands for El Nino and SO stands for Southern Oscillation. Because ENSO phenomena mostly occurs at the southern hemisphere, just right below the equator. And when you look at the term oscillation, it gives us a hint that something oscillates from one place to another or back and forth. If you want, you can pause the video and think about what could be that thing. Well, it's the temperature that we are talking about. And not just any temperature, ocean temperature. It is the ocean temperature that oscillates back and forth from warm temperature to cold temperature and vice versa. Now, the next question that should be in your mind is, which ocean are we talking about? I'll give you a hint. It's the largest one, Pacific Ocean. You see, Pacific Ocean is this large pool of water that exists on the western side of the American continent and eastern side of the Asian and Australian continent. This large pool of water gets intensely warm due to the fact that it exists right at the equator. And we all know that the equatorial region receive great amount of sun rays all throughout the year. So far we have learned what and where ENSO takes place. Now it's time to know how it all happens. To understand how ENSO occurs, we will need to break it into three phases. That's how it will make sense, and step by step the concept will get clearer. The first phase is neutral phase. Actually, there is no such thing as a neutral phase when it comes to any of nature's phenomena. You see, nature has a constant ongoing cycle that has never stopped. But for our own understanding, we will have to create a neutral state where we can see how a particular thing starts and goes on. So the first phase among the three phases is the neutral phase. In this phase, the central Pacific Ocean is warm. Now let's bring in the trade winds. Trade winds are these wind that blows in the tropical region from eastern side to the western side. They are also known as tropical easterlies. So as we know that the equator receives great amount of sun rays, and that's what warms the Pacific Ocean. The trade winds pushes the warm ocean current towards the Asian side because trade winds blow from east to west, and that makes the western Pacific Ocean warm. You know the region around New Zealand, Australia and Indonesia. This region is called the Western Pacific Pool. Here the ocean temperature is warm. The warm ocean current affects the surrounding atmosphere by increasing the temperature as well as the moisture content. And we know that warm air rises high into the atmosphere. It is through the convection process, and that's how clouds are formed, and then it rains. The warm air then travels east towards Eastern Pacific Ocean. You know the region near South America, especially countries like Ecuador and Peru. The warmer air, when it goes up, it reaches the end of troposphere. And if you know, the top of the troposphere is cold. When warm air meets cool air, slowly it loses its moisture content and the air becomes dry. The dry air travels towards the eastern Pacific side and comes down over the Peruvian coastal region, making the region cold. This pattern of rising air in the west and falling in the east continues, and it is known as Walker circulation. So this was the neutral phase. I hope you understood this cycle. It's plain and simple. Now comes the second phase. It's called El Nino. So in the neutral phase, we saw that the trade winds played an important role in pushing the warm ocean current towards the western Pacific. Now in this phase, the trade winds are weak. Yes, there are few months in a year when the trade winds are weak. When the trade winds are weak, the warm ocean current do not get any kind of push. So what happens is, the warm pool of ocean water at the western Pacific slowly moves towards the central and eastern side of the Pacific Ocean. So this is where the oscillation term comes in. You see, the warm ocean current is replacing the cold ocean current that exists in the central and eastern Pacific. When I say replace, what I mean is that the cold water is dense and it settles down in deep ocean, and warm water goes up and takes over the surface of the ocean. Okay, I hope you're understanding. When this warm ocean current moves, everything that is associated with it, like the convection process, then the formation of rain cloud, everything moves along with this warm ocean current. What you will notice now is that the Walker circulation that we saw in the neutral phase, that one big looping pattern, it's now breaking into two parts. Just look at this loop. As a result, the ocean temperature near Australia is cool and there is no rain, though the inland parts of Australia witness a severe drought condition. But on the other hand, near the Peruvian coast, the warm pool of ocean current brings heavy rain, flood to the American continent. So whenever you hear the word El Nino, immediately think of warm ocean current. And the third phase is La Nina. This is similar to the neutral phase. In this phase, the trade winds are strong. Since trade winds blow from east to west, hence it pushes the warm ocean current from the eastern Pacific towards the western Pacific. Now imagine this. Cold water is dense and it settles down in deep ocean. So that means the temperature of the ocean surface is warm. Now, if the trade wind pushes the warm surface ocean current towards the western Pacific, the cold water from the deep ocean immediately comes up at the surface. There's a word given to it. It's called thermocline. Thermocline is the rising path of water temperature. And the rest of the process is same. We saw that in the neutral phase. Western Pacific region of Australia, Indonesia, New Zealand gets heavy rain storm. The effect of La Nina is more on these countries than El Nino. So El Nino is a warm ocean current and La Nina is a cold ocean current. Remember that. If El Nino is at the eastern Pacific, then La Nina will be at the opposite region, that is western Pacific, and it oscillates back and forth.